What the AMS does is it uses a computerized hydraulic system to offload the weight of the astronaut in the suit. The astronaut suit weighs 350 pounds. So when they put that on, they weigh a lot. So basically we put them on this Argo system and we dial in any gravity level that we want to dial in. So if we're working in microgravity, we would dial in basically 0 gravity, and all of a sudden they would lift up and it would be like they weighed microgravity. If we wanted to simulate an actual experiment on Mars, Mars is 1/3 our gravity on Earth, so we dial in 1/3, and all of a sudden the computerized system lifts them up as if they had 1/3. The Moon is 1/6 our gravity, so we dial in the Moon as well. So basically we can put our astronauts in spacesuits and we can simulate any type of environment for them to do testing on. So what we do is we take this mock-up of the AMS. We have the scientists and engineers come from Italy, from around the world, and we have them come here. We put one of our astronauts in a spacesuit, we put them out there, and the astronaut and the technicians and the engineers can sit there right next to the astronaut and tell them how to maneuver, what things they need to do. And then once we develop those procedures, then we take them down the street to our neutral buoyancy lab, and we put them underwater, and we have them simulate the exercise underwater. Anytime we do anything in space, we practice it at least 7 times in the water. So we use our neutral buoyancy lab quite a bit, but the step before the neutral buoyancy lab is to actually go through the procedures right here where the engineers and technicians can work hand in hand with the astronauts side by side. So that's what we use this facility for. And you can kind of see here some experiments that we've done. So I think that's, it looks like 1/3 gravity there, so it's probably on Mars. There's So this end of the building belongs to the engineering director, which is one of the organizations that I work for. This is our robotics lab. So it took us 15 years to build the International Space Station, but we built it all using robotics. So basically that robot arm right there is the Canadian robot arm. It's a 1G model. That big monstrosity is actually what's in the shuttle payload bay. We used to use this into the facility to train the astronauts in how to maneuver and operate the payloads, the big large modules that make up the space station. We used to train them how to do that down here. Now that we've retired the space shuttle, we use this area for humanoid robots. So we learned how to do construction of a spacecraft in space using large robotics. And now we're building humanoid robots to help in building habitats and things like that. So when we learned how to build the space station, it took us 15 years to build this huge monstrosity of a spacecraft that travels 17,500 miles per hour. So now, when we go to Mars, we will not build the vehicle here on Earth. We'll build all the components and parts. We'll actually assemble it in space. That will allow us to put a much larger spacecraft together to be able to make the 8-month journey to Mars. So once we get to Mars, we need humanoid robots to be able to help the construction phase. On the way to Mars, we need humanoid robots that live outside, on the outside of the spacecraft. So let me show you our construction of robots.